Okay, we're going to look at a couple more volume problems. These are a little bit different because this one is talking about a cone. Now, a cylinder has a circular base and goes straight up. A cone has a circular base and goes up to a tip, kind of like a sugar cone or like a party hat, something like that. And it tells you that, in this case, the height of this thing is 17.1. So in other words, if I went straight down from the top, making a right angle with the base, that would be 17.1. And it also tells me that the circumference of the base. So in other words, if I was taking this base and going all the way around, it would be 16.3. Now, just like I want to start with the area of the base times the height for a cylinder, I still want to start with that for a cone, and there's going to be one key difference though. It's going to be the area of the base, and since the base is a circle, that's pi r squared times the height. But since this comes to a point, I have to stick a 1/3 because you can see most of the area. If it was a cylinder and going straight up, I've lost a lot of my area inside that green cylinder. Shave it down to the blue cone. I actually lost 2/3 of my area, so that's why I only have 1/3 left. You have the 1/3 in front. Now, to solve this, we're going to have to know what the radius is, and I don't know the radius because all they gave me was a circumference. So I'm going to pull out the formula for circumference. Is going to be 2 pi r, and if my circumference is 16.3, I'm ready to find out what my radius is. So the first thing I'm going to have to do is review kind of what we were doing last week. Divide by 2 pi to get your radius. And then we'll go into Desmos. And, well, I could put that in Desmos, but I'm actually just going to leave it in my unsimplified form for my radius and just let Desmos handle it all at once. Because if this number right here is my radius, now I'm going to plug into this formula here and get my final answer. I'll switch colors to keep things from running together. I have 1/3 pi and then r squared, so it's going to be 16.3 over 2 pi square times my height, which was 17.1. And once again, there would be no problem with going ahead and getting a decimal for r and plugging that in. If you did that, you'd just be sure that you needed to keep several decimal places. If it wants it to the nearest tenth, you would probably need to keep 3 or 4 decimal places until the end of the problem, and that will avoid you having rounding error. So let's go ahead and try typing this in. So I'm going to start with my 1/3 since it's a cone and comes to a point. The base is pi r squared. Remember, my radius was 2 pi. Actually, my radius, was 16.3 divided by 2 pi. That's going to be a little interesting to get that in now. I have to do a little cleanup there. And times my height, and my height I believe was 17.1. We'll double check that just to make sure I can remember my numbers, and I did. So that should be your answer for the volume of this thing, 46.45. The 5 will round it up, so you'll have about a 46.5 for your answer there for your volume. Now, we're going to try one more that's going to be similar because this one is a pyramid. Now, pyramid, once again, also comes to base like point like a cone, but it just has a polygon base. In this case, they say the base is a square. It can be any kind of polygon, a triangle, octagon, but usually for these exercises, I think we're going to have a square. This time they were nice enough. Instead of giving us something weird, they gave us exactly what we needed. A side length of the base is 16.7. And then the height, once again, is if you drop it straight down to the middle, the height would be 18.5. So the formula here is going to be 1/3, because if I were to do just show you one more time. If I were to come straight up and do a prism, you can see that I've lost a lot of my area by only coming to a point instead of shaving it all the way around. So I've lost about 2/3 of the area. That's why you get that 1/3 there as part of your formula for these pointed things, whether it's a cone or the pyramid. 1/3 times the area of the base. Since the base is a square, the area would be 16.7 times 16.7, because the length times the width would give me the area of any kind of a rectangular shape, including a square, and then multiply that by the height. So it's 1/3 the area of the base. Since the area of the base was a square, it was 16.7 times 16.7 times 18.5. I think if I just type that in Desmos, I'll have the answer we need. So let's go ahead and give it a try. 1/3, 16.7. Save yourself some time. You could do 16.7 squared, or you could type it in twice, your preference. 18.5, and to the nearest tenth, that's 1719.8, I believe. So that should give you the correct answer there, 1719.8, and that's how you get the volume of these pointed shapes, the cone or the pyramid. They have the 1/3 because you've lost a lot of the area by it shaving down to a point.